So good morning, good afternoon, good evening, ladies and gentlemen. It's my pleasure to welcome you to the Mnify webinar. My name is Joseph Johnson. I'm a sales engineer here with Mnify in the Berlin office. I have a long history in the telecommunications field with Ericsson and Motorola Solutions, working on various technologies, core networks, transmission networks, fleet management, hybrid devices. And it's my pleasure to introduce you to my colleague, Christian Henke, who will guide us through the webinar today, while I'll be looking after you and keeping an eye on the chat and the questions that you might have. Christian, over to you.
Okay. Hey, JJ, thanks for the introduction. My name is Christian Henke, and I'm Director of Product Management at Mnify. So I'm looking over here at over the platform, networking and connectivity. And previously I've been working with Tektronix and NetScout, so in the mobile network space, specifically looking at radio access technologies. And I'm really excited to present to you today kind of a new technology which is coming up, which combines cellular and satellite IoT connectivity. I still would love actually to give a couple of registrants the chance to join. I see that there's still people coming in. I know for Europe it's already a little bit late. You can see here's no light outside anymore, whereas in US people are just may just be getting up.
Please feel free to submit questions in the chat during the webinar. I'll interject and ask Christian your questions. And we'll also have a couple of polls during the webinar to make it a little more interactive.
Okay, but I would say we start. Quite an interesting topic. I'm sure you already have some questions. As Joseph said, please just submit them and we will intertwine them within the presentation. So, but let me just give you, kind of a hook to today's webinar. So we as Mnify, we are a cellular connectivity provider for IoT, and our goal is to connect your devices wherever they go. Yeah, anywhere on the globe, no matter if you have mobile or stationary use cases and you ship your devices to areas you never had customers before, we want to make sure that your devices are able to connect. And up to now, we always have been choosing cellular connectivity to reach that goal. And for that, we onboarded more than 600 mobile network operators in our roaming footprint, and with and have as the only non-mobile network operator the largest roaming footprint across the world. And we also use partners to even increase that coverage. Now, as you can see here on this graphic, even we think we have a really great coverage. There are a lot of coverage gaps which cellular cannot fill. Of course, mostly in dense urban areas, cellular connectivity is sufficient, but we also see customers deploying connectivity and IoT solutions in areas where there may not be any population. And that's where it gets interesting, of course, especially where there are no people. You want to at least have a machine or something that can tell you if something is going okay or wrong. And here, satellite, of course, could be an option. And of course, satellite solutions are already available. But talking to our existing customers, satellite brings several challenges just because of its proprietary technology. So it's not only quite costly from a hardware point of view, so you cannot combine cellular and satellite currently into one device, but you have to have two different devices actually to connect to both technologies. But you also need your own satellite subscription, which can be easily above $30 per month, even without any data included. And also this connectivity may not even have a management platform or have a complete different one to the one that you use on cellular. So this is why we think satellite may be a solution today for limited use cases, but what if you would have the chance to connect with a single device, with a single cheap device, not only to cellular over Narrowband IoT, but also have a fallback to satellite connectivity. So this is what this webinar will be about. And usually kind of when you introduce new technologies, you describe the typical use cases for this technology. But I believe you have your business case. You already are in the IoT space and have your use case where you want to understand how you can get more market share. So I will skip this because not everything that is even shown here in these industries would be solvable by this new technology. So let me give some overview about what this new technology, satellite over narrowband IoT, is feasible. So of course, taking again the first map view on the beginning, of course, satellite has the intention to fill all the coverage gaps where cellular connectivity is not available. So things like oceans, deserts, rural areas, or also larger lakes, border shores, all these areas where cellular connectivity infrastructure is not present. But I would even say in urban areas where there is just because of the infrastructure, there's no cellular connectivity available. Now, satellite, of course, is not a solution to close all these coverage gaps. For example, satellite, as you can imagine, is not working indoors. And it is also not a solution if you need to have low latency of data. The transfer of data through the satellite is taking a significantly more time than taking cellular or Ethernet connectivity. And also, as you may already can see from narrowband IoT over satellite, this is also not a technology where you have a high throughput of data. But narrowband IoT over satellite gives you coverage where you would not have any before. And sometimes, even if you're not maybe able to send a picture from the situation, maybe it's just sufficient to send small information that something is good or bad at that certain location, and that might be sufficient. So from a use case perspective, if the solution is stationary or mobile, you can differentiate. Yeah, if you have, for example, your device stationary in, let's say, in mountains, and there is no cellular coverage, then of course there will also be no cellular coverage happening ever. So you could use that device just to use satellite connectivity. But there can also be stationary use cases where you have intermittent coverage changes. Yeah, I'm thinking about seasonal effects, for example. If you have cellular coverage in winter, but due to leaves coming out, then you may not have cellular coverage in summer. Then satellite can give you a fallback solution in case you lose that coverage, and you would still be able to serve your customer. In mobile use cases, I want to make two things aware. Of course, for mobile use cases, a satellite is also a feasible solution if you, for example, have a container tracking solution in the ocean. Then most of the way the container will not be in cellular coverage, so you would use satellite. And if the device then goes through a harbor where there is cellular infrastructure, there would be a fallback to cellular connectivity. But what we don't see as a feasible solution if you have fast changing coverage availability. So for example, if you want to send every minute a device location and you often cross coverage holes which are just for a couple of minutes, then satellite and narrowband IoT narrowband IoT over satellite would not be the right technology. But now that I maybe gave you some of the hints, in which coverage situation and which scenarios narrowband IoT over satellite would apply, I would like to get some more information about you, just to also get some understanding about your experience and what you would imagine how this technology would change your business. So we have a small poll prepared where we just want to first understand: are you already using satellite, or was it currently just because of the complexity and of the solution not a viable solution for you? So we'll start a poll.
I have launched the poll now, so you should see it. Plus, we have a few questions from the audience while the poll is being filled in. So the first question is, why NB-IoT and not other LPWAN cellular technologies like LTE-M?
Very good question. So in general, the technology is defined for a narrowband IoT, LTE-M, and 5G. So from a standard base, I will talk soon about the satellite operators that are starting to apply or implementing this standard. And from all these satellite providers, their feedback was they are starting with narrowband IoT over satellite, and LTE-M and 5G is later on their roadmap, and this is why we're focusing here on narrowband IoT. Nevertheless, most of the devices that are available are LTE-M devices, also have narrowband IoT capability, so that would enable also customers that already use an LTE-M device to make use of that technology.
Another question here is, what do you think about applicability for LoRaWAN?
There are solutions available or also planned for LoRaWAN, and I actually will show which satellite providers are going into that direction. But LoRaWAN would have a similar drawback compared to existing LoRa solutions right now, that basically you could not roam to the terrestrial network, so we would always use the satellite one, which I would say even let's say the whole technology will bring down the total cost of ownership. Still, the data transmission, the pure data transmission of over the satellite is still costly and should be considered carefully.
Another person is asking if Mnify only views this as a fallback technology.
I think I mentioned that there is, dependent on your use case, right? So we want to enable you to use, if you send your device to an area where there is no cellular coverage, then your device would get satellite only from us, yeah? And if the device is going to an area where there might be satellite or cellular, then there would be the fallback. So we don't just consider it as a fallback, but for us it is basically enabler for you to connect your device wherever through whichever technology is available at the point where you deploy your device.
With that, I'd like to go back to the poll and close the poll so we can show you the results. So last vote's coming in now. So, and let's share the results. So Christian, what do you make of our results here?
I have to, it's so small, I have to.
Maybe I can read it out for you. 84% say that they are using 2G, 3G, 4G. 21% say satellite. 53% NB-IoT LTE-M. 21% exactly the same satellite. LoRa, Sigfox, and Zigbee. And 11% not applicable.
I find this very, very interesting in a sense. We already have here a group that are very familiar with the satellite technology and with the implications. And I'm also see, narrowband IoT and LTM is widely used. So this is also what we see from our customers and our platform, that narrowband IoT and LTM is gaining large market shares, also because of the 2G and 3G sunset. Yeah, and really interesting results for that. But I think as a follow-up question, I mean, I presented, the cellular coverage gaps and, in the areas where there would not be a coverage. What would you kind of, what do you see, what could you imagine would be kind of, if we recall a past project, what was the impact of not having coverage in terms of revenue? Just to get an idea, how important is it for you to have something else that can close cellular coverage gaps?
And if you have any questions in the meantime, feel free to ask. One of the questions was, will we discuss only NB-IoT or also LTE-M over satellite?
So on LTM, there is little information that is available in terms of what the satellite providers are enabling. So it's basically a standardization item. So we will not discuss LTM over satellite.
Okay. And we have a question about the difference between LTE Cat 1 4G and NB-IoT. What are the main differences?
Okay, that is a good question. So LTE Cat 1 is a standard which is, for higher bandwidth use cases, so 5 and 10 megabits per second downlink and 5 megabits per second uplink. The nice thing about LTE Cat 1 is that it's the standard that is worldwide available in all the LTE networks, so not like Narrowband IoT or LTM. And still the devices are cheaper than broadband modules like LTE Cat 3 or Cat 6. And even some of the power saving features can be supported on LTE Cat 1 devices. And the LTE Cat 1, and sorry, Joseph, can you repeat the question? I don't know if I answered it correctly.
Let me show. It was what are the main differences between LTE Cat 1 and NB-IoT?
Oh yeah, oh sorry. Okay, so Cat 1 is worldwide available and has, for example, we as Mnify can offer roaming agreements across all the world and connect devices with LTE Cat 1 across the world. Whereas for narrowband IoT, there's challenges with roaming access. Narrowband IoT has some improvements in terms of, first of all, module pricing, so a lot cheaper, about 1/3 of LTE Cat 1 module and Narrowband IoT has improvements in coverage and power saving as well. But actually, we had a webinar around that on cellular technologies before. We could also share a link about the different technologies.
And one more very interesting question before we close the poll. What satellite providers are expected to offer services and be available with Mnify SIM cards? And some names are mentioned here, like Starlink, OneWeb, Coopier.
That's a very good question, and I will exactly show this. We interviewed or had conversations with more than 30 satellite providers and grouped them, and we're looking for the right partners to fulfill our vision. And I will show this in a couple minutes.
Perfect. So with that, I'd like to close the poll and share the results. And here we go. So we have a very interesting distribution. It's not often we see such a curve like this, but we seem to have two leaders, 1 to 10% for almost a third of the audience, 29%. 10 to 20 is only 12%. 20 to 40 is 18%, but 40% plus, 29% of the responses say this is the impact due to lack of outdoor coverage. And 12% not already using satellite or no impact.
That's, I have to admit, really surprising results. I mean, this speaks that probably we have several use cases here in the webinar that are having coverage gaps and have use cases that are specific for exactly these distant areas. And yeah, would really love to know more about the use cases, and if Narrowband IoT over satellite would be able to solve this. So let's dive into this, so that you get a little bit more understanding about the technology, and if this is really the technology that can help you generate the revenue, so that you're kind of have missed before.
And with that, I'll hide the poll, and Christian, you can continue sharing your slides.
Yeah, I hope it does it automatically. Nope. Okay.
No.
Let's throw on this. Here we go. So this is about the agenda. So everything before was a little bit of an intro. So I will give an overview about the Narrowband IoT over NTN technology. Then, as I said, we had conversations with more than 30 satellite operators to identify the ones that were offering the new technology and with we would like to partner. And then probably a very important thing that is relevant for you, timeline and things to look out for when using this technology. And I want to give you a rough idea about Mnify's vision to offer satellite over narrowband IoT. As I will show, the technology is not yet available, so this is not that we are currently offering it, but we want to make you aware that we will offer it in the future, and we're working with the partners to come to an offering which will meet your needs. So from a setup point of view, you can imagine, let's take an example here of a fleet management use case where your device is on a mobile car and it's connected through regular cellular connectivity and can send data to your application as it does today with using narrowband or LTM. But if the device is then going out of cellular coverage, the device can also use satellite, the satellite network. And from a setup, for satellite, you always need to have two links to the satellite. So the service link, so from the device to the satellite, but also the satellite needs to have a link to a ground station in the same view, or so that the data can be sent from the device back to the ground, and at the end up again in your application server. And in order to enable such a scenario, there needs to be a cooperation between the satellite provider and, of course, a provider that offers cellular connectivity. So this would be then Mnify. And the integration of this satellite connectivity is similar to a roaming scenario. It's similar, like we enable access to other mobile network operator networks. We would use here similar technology to enable also roaming in the satellite network. Now, we had the question before. Yes, the technology is standardized for narrowband IoT, LTM, and 5G. But again, the satellite providers we have been talking to were exclusively focused on narrowband IoT, also because I think from a bandwidth perception, if you talk about LTM and 5G, that's complete different requirements. The technology will use frequency bands in the 1.6 and 2.0 gigahertz bands. So this is similar to LTE. So it's actually the N255 and N256 bands, which are similar to LTE band 65. And it kind of will look like the device just sees an additional narrowband IoT network with the mobile network and country code from the satellite provider, and the device would then be able to connect to this satellite network. So to understand more about the technology, we have to talk about satellite constellations. In very simple terms, there are three types of satellite constellation: low Earth orbit, medium Earth orbit, and geostationary orbits. So the geo constellations, they basically the satellites have always the same view on the globe, so they always have the same cell footprint and are stationary. Of course, there's larger delay to send data through geostationary satellites, but the benefit of such a constellation is that you need just very few satellites to actually cover the whole world. Nevertheless, these geostationary satellite constellations are really expensive. And this is why you have also seen other companies like Starlink or OneWeb actually launching LEO, low Earth orbit constellation, which are just less costly. So sending up a satellite costs less than $5,000, for example. And LEO constellations have been not only been used for broadband, like with Starlink, but also for maps or map services to get a constellation up and running. The benefits from a low Earth orbit is also that the satellites, they have to use lower power to send the data. There's lower delay, but there's one drawback, and that is, as you can imagine, if the satellite only has a smaller footprint, if you need continuous global coverage, then the satellite constellation needs to at least have 60 satellites, so that you have multiple sites of a satellite per hour, for example.
And we have a question here on this slide, and that is, which one best supports an edge computing application?
Oh, that's a difficult question. An edge. Well, in edge, the reason why you do edge is usually because you want to lower the latency, right? So, or you want to, for me, there's two reasons to have an edge solution. So you want to have a low latency solution, or you want to basically not send as much data back to the cloud. Yeah, and if you of course want to use low latency, then the LEO constellation is the better solution. I don't know if that answers the question.
Yeah, feel free to answer to ask a follow-up question as well. And also, of course, the bandwidth considerations must be taken into account. So if you require high bandwidth and low latency, narrowband IoT, okay, it's answered. So I won't waffle on too much.
Okay.
And we can move on. Okay, thank you.
Okay. So this slide tries to summarize how as I discussed, we interviewed or spoke with several satellite providers to find out which are the right partners to launch such a solution. And here's kind of the grouping of the different technologies. So in the middle, you see several incumbents that are currently providing satellite connectivity. And the solution is proprietary. So with their own device hardware and separate from any cellular connectivity. And then there are these new enablers on the right side, LoRa and Sigfox in Bluetooth that may also use a LEO configurations that also go in the direction of LP1 constellations. And on the left side, we identified two relevant players, and that is Skylo, a US-based company that has a geostationary constellation, and Satillo, a Spanish satellite provider that is building up a low Earth orbit constellation, and it has a very strong partnership with the Telefonica group. And actually for Satillo, Mnify is already the preferred testing partner. And we are actually at the end of the webinar, we also want you to give you the chance to be part of that preferred testing partner program. And then there are here also two players kind of in the middle in between. This is Link and AST. They're not implementing Narrowband IoT over satellite, NTN, non-terrestrial networks, but they are actually connecting standard wireless technology through satellite, but there comes a drawback with that technology because that would require that both of these satellite providers get regulatory approval from every country to use a spectrum there. So usually they partner with operators to get that. So they only have limited deployments across the world. Link therefore specializes on oceans where there is no spectrum required, and they are offering SMS connectivity already in these areas. So I guess one of the most interesting and also here internally most often asked question is, when is this technology production ready? And the technology, the standardization has been finished in September. They are really great partners that were part of the standardization, all the players that are needed in such an ecosystem. So you have the chipset manufacturers like Qualcomm, MediaTek, Sony, Huawei, and ZTE. And although there's currently no chipset available, um, we get the feedback that an estimated time is mid next year. We're really looking forward to that to enable first testing. Of course, for most of the solutions, you would require then a certified module that uses the chipset. So u-blox, Telenet, Sierra Wireless, your preferred vendor will need to integrate these chipsets into their modules, and then we see that an availability at the end of next year is possible. Nevertheless, and I will come to that, there are also some ways to enable existing devices, but that we will be then with limited functionality. There's, besides the device side from a device, a module and chipset, there's of course also the satellite provider that needs to have the constellation up, has to develop a 4G core network to enable Narrowband IoT, and also has to ensure that local regulations are met in the countries where they want to provide service. So Skylo has the advantage that they are using a geostationary constellation which is already existing. At the end, they are reusing an Inmarsat constellation. This also already gives you an idea that from a data connectivity pricing point of view, there may not be a big difference, but of course from a total cost of ownership, because you can just use the same module for satellite and cellular. Satelio has already launched one testing satellite last year, and in Q1 next year, they will launch the first production satellite, and they will bring up their satellite constellation up to 256 in 2024. And then there is, of course, also the network integration required, and we are already in discussions with Satelio on the design, how we want to do this, and we are planning a proof of concept instrumentation in mid next year, depending, of course, of the availability also on the Satelio side.
And by the way, we have a couple of questions. If we go one slide back, there was a question about Starlink, especially the V2 cellular service, as they will be using LTE band 2. What about that as an option?
JJ, do you have maybe there some more information?
Yeah, of course. I've looked at this many times because it's created a lot of attention. And indeed, a lot of it depends on the regulatory approval and borrowing LTE band 2 frequencies from operators. So what we see is that they have a vision to work with an operator like T-Mobile US, borrow their frequencies and ask the FCC to do something non-standard with standard GSM frequencies. And this is it could easily get approved for use in places like Hawaii and non-mainland US. But where it runs into problems is when you're touching the border between the US and Canada. And the Canadian regulators will take a completely different view. And we don't expect this approach, this non-standardized approach, to be particularly well looked upon. In some cases, yes, and in some markets it will work, and then with some operators. And there's so many ifs and buts that it isn't really a standardized approach. And if it works with a T-Mobile SIM card, that's nice. But for our customers, it's more of a global solution that should work all across the Americas, where it should be easily approved, so that in that footprint of the geo satellite, that'll work in every market, and it should be just a matter of approval, like the Iridium satellite network or the Globestar satellite network, and not so patchy. Another question is more of an administrative one, is that will this webinar be recorded and available afterwards?
That's the most asked question in any webinars, of course. Of course, yeah, we will share the webinar recording and the slides afterwards with you.
So I think that's all the open questions for now.
Okay, I think we also get to a very simple Mnify satellite vision. Yeah, so we want to keep it simple, simplify connectivity, and the way that we envision to offer satellite connectivity is the same way as we have been offering cellular connectivity. So with a single global eSIM, we will enable cellular satellite in any network worldwide. So you will be able to use your single device in dual mode, so with narrowband cellular or satellite connectivity, and it will be enabled also on the current eSIMs that we are shipping today. And as in Mnify already applies today, so no matter where the SIM card is located or your device, everything will be managed in the single platform with the same functionality, single bill and single support. So all the functionality that you already know from the Mnify platform, we will also enable for satellite. And this will also already give you kind of an idea, the ones that are more familiar with the platform, how we will offer this, as we will create a specific rate zone coverage policy where you can then activate satellite for those devices there where you see it necessary. But I also would like to just put a very simple checklist for module requirements, then get an idea what are the capabilities that the module needs to support to make use of that functionality, and also kind of what are the expected impacts. So as you can imagine, this is a new technology. Not everything is yet figured out, yes, but some things are already clear, which is what is possible and what not. So the module needs to support this new narrowband IoT over NTN functionality, which is specified in release 17. The hardware of current narrowband IoT devices that support LTE band 65 are theoretically updatable to support this and could make use of that service. A requirement would be also that this module supports GNSS, so as a GPS receiver, could also be an external one. And then the nice thing is there would not even be an antenna change because the frequency bands used are the same. And also the satellite providers confirmed that PSM and EDRX, so the both power saving modes, will be supported on also in their technology. One thing which you cannot expect from such a modem is that you will get the throughput of a regular narrowband IoT device. So narrowband IoT has something up to 100 kilobytes per second, but actually in real life we know it's more 10 kilobytes per second or less. It also depends on the 3GPP release the device is supporting. For narrowband IoT over satellite, the expectation is more that it's a single-digit kilobits per second throughput. So it will take some time to send data over the wire, and with that, of course, there will also be a little bit of increase of power consumption. But in general, as I think I said before, this is not a technology where you get the same amount of data like in a regular cellular setup, but it will be limited data. But limited data is way better than not having any data at all. And also from a cost perspective, we think you need to look into how you can optimize the amount of data that you send over that technology. And there also comes the other change compared to regular narrowband IoT. The packet size that is supported on narrowband IoT is 1,500 bytes, whereas the packet size over satellite is dependent on the provider, something between 50 or 250 bytes.
So we're good. We're running into the last 13 minutes, and the first people are already saying thanks and have to go. But yeah, we're doing great.
Yes, actually, we're kind of also getting to the final FAQ section or to the questions. There were always some questions that were always asked, like firmware update sufficient? Yes, the satellite providers for testing purpose, they already enabled, with the help of some chipset manufacturers, existing devices to use that technology, but there's no generally available firmware for that. And I kind of doubt that the device manufacturers will release that without basically monetizing the new hardware. Think about 5G narrowband IoT, we already spoke. Not to confuse, it is still the narrowband IoT technology that is available today. It is just using these other frequency bands. Yeah. eMTC and LTM support, we also talked about it's standardized, and I'm really looking forward because on a cellular level, LTM is way more powerful than narrowband IoT. But actually the limitations of narrowband IoT, that there is no roaming, is in the satellite case not applicable. Yeah, and this goes to the last point here on the slide. Narrowband IoT, I always heard this is not meaning for mobile use cases. No, if your device is moving, narrowband IoT has some drawbacks that narrowband stays longer connected even to a bad radio connection and tries to still send data. But you can enable, and we have several customers that enable also mobile use cases with it. Okay,
And
so
we have an additional question again. Maybe you can go back to the relevant slide, and it's about when will satellite connectivity be available? So some of our attendees have clients, and they would like to know when will it be really available for their clients to use?
If you're building a device, yeah, so you basically have to take you have to have all 4 components, yeah, and the device currently is the one which is kind of giving the timeline for it, yeah, the module. So here we see something end of next year, and that is, I would say, the kind of timeline where we see that there will be production, commercial quantities available to enable connectivity over satellite. Okay.
So, and feel free to ask any other questions. Some of the other questions that I often get asked are about the power, for example. Are there any power considerations when using satellite as opposed to terrestrial networks?
So in general, the narrowband IoT devices, they have different power classes. So they cannot, consume more power or send stronger signals just because they're using satellites. So that there will be no change. There might be an impact because of the lower throughput that is possible when connecting through satellite.
And then I always get asked, does it cost more than a standard terrestrial service?
Yes, I think I alluded to this before. Of course, cellular connectivity, the infrastructure is there and is a lot more simple than in space. So the data connectivity costs are, of course, significant higher. But I cannot share yet any pricing. Actually, this is a good point because here in we also have an exit interview. Yeah, so we want you to actually have the possibility to participate in the early test program with us. So we would inform you about the changes if we, find the right module manufacturers or chipset manufacturers. If there's some updates, we would inform you, and also we can do joint tests. And also in the exit interview, we would be asking some questions, what would be a viable business model for you? Because also if we talk with the satellite providers, they're still figuring out how they want to price for that satellite connectivity.
Indeed. And with that, I'd like to call it a wrap. And thank you, Christian, for your time and the information. Everybody was very happy, and thank you everybody for your questions. And I hope that we can have nice follow-up conversations and a nice testing phase. And if there are follow-up questions, please reach out to us as well. And we'd really appreciate if you could fill out the survey at the end of this webinar. So
thank you.
Thanks, everyone. Bye-bye.
And bye-bye.